Good evening to everyone present here. It gives me immense pleasure to welcome you all to day 3 of our 7-day integration workshop on machine learning. Today, we move forward into one of the most important areas, foundations and classification. I am sure that under Mr. Yaser's guidance, today's session will be both intellectually engaging and practically enriching for all of us. On behalf of the organizing committee, I extend a warm welcome to Mr. Yaser and request him to take the session forward. Thank you. Sir.
Yes, madam. Thank you so much for the introduction. So I think, let me share my screen. Okay, respected faculties, coordinators, organizers, and my dear friends, good evening to one and all. I hope you are enjoying the brief sessions of AI and data science and so on. So before that, can you just type yes in the chat box if you can see my screen and if my voice is audible and it's clear? Just type yes in the chat box so that I can know my voice is audible and it's clear. Okay, yeah, thank you. So, well, yesterday, I hope I have taken the supervised learning and the forms of linear regression. Today, I'll be moving on to the two types of algorithm used in AI, that is naive Bayes, and maybe if time permits, logistic regression also. And I think we can do some of the basics of codings in Python or Colab so that you can understand those codes. And don't worry, sometimes I'll be in a hurry as per the time permits, because these sessions are, it might take more time to understand. But if you have any doubt, you can raise your voice, or you can just type in the chat box, or even you can email me for further clarifications of any of the type of doubts if you form, whether it is mathematical or whether it is coding perspective or application perspective. You can email me, or even you can ask me application level doubts also. Most welcome. So, well, today I hope I said you from the screen itself, it's very clear that naive Bayes. I think some of you know these things. So naive Bayes is a type of classifier. It's a probability-based classification algorithm. So I think, I don't know how many of you are familiar with the probability, but still I'll try to explain some basics so that you can recall it. So mainly it's used for sentimental analysis, then document classification, then medical diagnosis. You can use this algorithm. Then I hope you know something like recommendation systems in Netflix, YouTube, then what? Facebooks, Instagrams. So it's an algorithm which predicts the class and category of data using probability. So mainly Naive Bayes answers the question like given some features. I hope you know what is features from yesterday's or day before yesterday's class. So you have given some features. What is the most probable class? So you can think of many of the examples like all features are independent from each other, and this actually this assumption is also called a naive assumption. So in reality, many words, many textures, patterns may be related, but naive Bayes assumes each word in the features contributes independently. Even though this assumption is unrealistic, this algorithm works surprisingly well. So actually, let me move on to the slide. So I hope you can see the screen. So in the classifications, so yesterday I have given many examples in the intro. So how can we classify something as something? So whether it is cat classified as cat, whether a cat is classified as dog, whether a cat is classified as tiger. So what are the reasons? There will be certain reason. So you can see there are certain features which classify the cat as cat. So you can see in the screen. I hope you can see the moving pictures. So there is n number of features in which classification happens. Okay. So these types of classification you need to determine. So actually we are trying to find out the reason in the form of some features where something might happen. So actually that is you mean by, so you can see why did this model classify this image as cat. So you can see the images showing the classifier looked at some features or attributes. Certain attributes had very high importance, maybe the cat's eyes, or maybe the cat's mouth, or maybe so it depends to person. Some may be looking the ears, some may be looking the eyes, or some may be looking the what is it's called the beard or the mustache. So it depends, right? So the model is focusing on different things. So the model learned that the pupil shape or the size is important to identify the cats. So now connecting these things to the naive Bayes, in naive Bayes classifier, the classifier assumes each feature independently contributes the final prediction, whether it is ear shape or eye shape or pupil size or fur texture or the nose shape of the cat. So actually, naive Bayes calculates the probability. So actually, what it calculates probability that the cat given features. Okay, cat. I hope you know you will be aware of the basics of Bayes theorem. I'll show you the slide. Don't worry. So the probability of cat with the given features actually it is calculating. And well, for the cat, the ear shape is independent. We are assuming that the eyes shape is independent, the pupil size is independent, even though it in reality may be related, depends on the creatures. So we compute the probability ear given the cat, the probability of eye given the cat, the probability of pupil given the cat. So it depends. So different features given the cat, we are we are multiplying the probabilities, and finally with the given features, we are predicting that as cat. So that is something what is coming in the probability. So suppose you can see in the picture, so you can see this, I'm sorry. So you can see a sample data set. So I think you can zoom it and check. So here there is a data set which is predicting if a person is having a cancer or not. So there are n number of reasons to for the disease of cancer. It may be like junk foods, or if you are not having proper exercises, or if you are smoking or drinking alcohols, or if something, or genetically even. So the main assumption in the naive Bayes is all the features that predict the target value. So what is the target value? Whether you have a cancer or not. So you can see if you have a cancer, it is predicted as 1. If you don't have a cancer, it is predicted as 0. I hope you can see the screen very clearly. So it depends. So if I think with the first feature X1, you can see if the age is greater than 50, So if the age is greater than 50, it's 1. And if the age is less than 50 or equal to 50, it's 0 they have classified. And the smoking history, whether the person, so what they took, they went to a hospital or they went to a regional cancer center, they may take n number of data. So this is how you prepare a data set. So you will take n number of patients, and you can take like say 50 number of patients of cancer, 50 number of patients, those don't who cancer, don't have cancer. So you can limit their age. You can check whether they are greater than 50 or not. Well, then you can check that whether the patient is smoking or not, or in family history there is any genetical problem with the cancer patients or not. Or you can check whether, so I think the cancer patient usually have weight loss, hair loss, maybe due to the treatment of chemo. So it depends, different types of things depends. So age is treated independently, smoking is treated independently, family history is treated independently. So this is something we do it in naive Bayes. So actually we are predicting the cancer diagnosis using the age, smoking, family history, and the weight loss. So yesterday we have done using the linear regression. We formed an equation and we mapped every y into x. So that what was we were doing. So we mapped every x into the y space. So this x, you're taking it in the matrix and then you're mapping into I, and y equal to something like mx plus c. So you can map this y equal to m times this x matrix plus c. It depends. C means it's just point intercept. That also you can calculate. So you're calculating the most optimized m C to get a function which relates these features into the predicted value. So what you're doing in naive Bayes is you are actually predicting the individual probability. So if you have the probability of cancer, so you're calculating the probability of age in cancer. Then you're calculating the probability smoking given cancer. Then you're calculating the probability of family. I'll show you an example, don't worry. Then you're calculating a probability that weight loss given cancer. And together you're checking whether you have a cancer or not. So what is the meaning? Maybe smoking does not affect the family history, right? Or age does not affect the weight loss, or all features contribute separately. So like this, you are checking. So naive Bayes actually multiplies all the probabilities. I hope you will be familiar with the Bayes theorem in the mathematics. So I'll show you. So like you can see that from the data set, older people are more likely for the cancer. Smokers are more likely for the cancer. I hope you know what is the word likely we use in the probability, right? So weight loss, those who have weight loss, you have more likely to have the cancer. If you have a family history cancer patients in your family, you are more likely to have a cancer. So when all clues combine, cancer probability becomes high. So probability means what? So I'm sorry. So what do you mean by some probability? So I'll just explain with some 1 or 2 slides what is probability. So I don't know how many of you are familiar with the probability. I think most of your teachers and especially computer science faculties, maybe I think so. I hope you have the basics of the probability. So probability is how likely something is to be happen, like probability of raining or probability of you have cancer, or in reality age and cancer are actually related, right? So usually we see mainly cancer for aged people. So maybe exceptional case will be that ideally mostly aged person like 40 or 50 or 60 or 70 aged people have cancer. But naive Bayes ignores these dependencies. Still, it works surprisingly well in many real algorithms. So, it predicts a class by multiplying the independent feature probabilities and selecting with this. So, I'll show you. So, what is the probability you can see? So, here the probability of picking a red ball is 3 by 8. So, the total is 8. So, just refreshing what is probability. So, because I'll be explaining most things in probability. So, what is the probability of picking a green ball at random? It's 5 by 8. So what is the probability of picking 2 balls without replacement? So one will be 5 by 8. Then you're minusing, it will be 4 by 7. So 5 by 8 into 4 by 7 is 20 by 56. So that is if you're picking 2 balls without replacement, the probability of that both are green means it will be 5 by 8, and then you're replacing it, right? You're not replacing it. So -1, it is 4 by 7. So if you pick one ball, replace it, and then pick other with replacement, what is the probability the ball is red? So it will be 3/8. Then also you are replacing it, and then the probability will be 3/8. So I'm going in a hurry. I think these things many of you know. So and even the coin toss example. So the probability when you toss a fair coin, that the possible outcomes will be head and tail. So I hope you know what is the probability it will be head and what is the probability it will be tail. Similarly, you might know what is the probability when you toss a fair die. So there will be fair die and unfair die. So let us assume the dice is fair. So the total outcomes when you're tossing the die will be 6. That is 1, 2, 3, 4, 5, 6. So the favorable outcome, maybe you can think the probability of rolling a 3, it will be 1/6. So similarly, if the probability of numbers greater than 4, it will be like 5 and 6, it will be 2/6. So probability measures how likely an event is to occur. So that is actually we are doing. In the cancer side also, in the cancer data set also, I shown you a cancer data set, right? So the patient data set. So here also we are checking for the probability whether a person is probable to have the cancer. So same uh, uh, basics of necessity we are calculating here. So actually, what you mean by probability means it actually measures how likely an event is to occur or how likely a patient is to have cancer. So the probability is always lies between 0 and 1. So if you have 0, it is impossible. If you have something like 1, it is certain. And if you have 0.2, it will be less chance. If you have 0.5, that will be 50% chance. If you have something like 0.9 or 0.8, you are very likely to have cancer. So it depends. So these are something which you need to know for the basics. So mainly, as I said, the application of naive bias is used in many of the algorithms, especially in spam filtering. So I'll show you one example. So how this probability is used in any one of the data sets. So these are something which we want to know, which is happening inside. So we all people use Facebook or something like so YouTube. So everything is doing the spam filtering. Google. So Google is sorting out the spam emails. So that is simply but naive bias. So something like sentimental analysis, it is whether your comment is a negative comment, whether your comment is something like positive or it's a neutral comment. So and even language detections. So nowadays you can translate any language to any language by the Google Lens, right? So these things are done by naive bias only. And even recommendation system. So when you buy an iPhone or any Samsung S26 Ultra, so next day if you buy, the next day they will show the cases. They will show something else like the charger. They will show something like the cable of S25. So it is something like recommendation systems. So how is probability used there? So we'll try for some examples. So to understand behind the naive bias, so let's go for an example. So let's try with the classifying some emails. So you can think that you are preparing some data set. So just assume I'm having a small data set of 9 emails. So I took like 1, 2, 3, 4, 5 emails as spam and 4 emails as spam. One small example. So I'm creating a data set. So you can see here out of 5 plus 4 emails, 9 emails, probability of spam is 5/9 and probability of not spam is 4/9. So then you can check. What we have to do at first is we need to pre-process the data. We'll create a list of unique words. So we want to check which word is more related for the email to be spam, or which is the word more related to for the email to be non-spam. So actually we'll create a list of unique words in the emails and their corresponding labels. So these emails you can think it's a data set. So it's only few number of emails. Usually you have to create data set with more numbers without any overfitting or the. So that is something cases far away. So let's you think we are creating a data set with email and non-email, and we have given the labels. So naive bias is actually a supervised learning technique. So you need labels. So you took 50% spam email and 50% non-spam email. What you did, you splitted the every unique words. So I have given the code to split each and every words in a data set. So these are some of the techniques you do while you are doing the codes. So actually, you're calculating the prior probabilities of probability of a spam. So out of 9 emails, you can see 5 email is spam, and out of 9 emails, four emails are non-spam. So as per this data set, you can see 1, 2, 3, 4, 5. So this is how it is firstly calculating the spam probability. Then actually, what is happening now? We'll calculate the likelihood of each word given each class. So this is done by counting many times each word appear in each class. So actually, what is happening here? So we are, by probability, we are initiating to check whether the given email is spam or not spam. So as you know, supervised learning means you need to teach the system. So we have, for teaching the systems, we have 5 email as spam and 4 email as non-spam. So we have to learn the probabilities. So what happens, the model counts the words, how much words are repeated in spam, how much words are repeated in non-spam. So word appearing in spam, but spam email contains anyway unique words must contain, right? So you can, if it is an original data set, maybe some will be repetitive in both spam and non-spam. So here I have done a normal data set which does not reoccur in both in spam and non-spam. So I have done it ideally to make you understand. So actually we are calculating it. So you can see the words appearing in the spam like buy, offer, then lowest, exclusive, deals, price. So you think these kinds of words become highly associated with spam emails. And words appearing in non-spam, you can see meeting, projects, schedule, updates. So these become associated with non-spam. So you're checking when a new email arrives. Suppose a new email says exclusive offer now. So you're splitting each word and checking each word's, each independent word's probability, given that is spam or not spam. So then you will give a probability for the words given spam and the probability for words that is not given spam. So this is how you calculate. So the model thinks some words usually appear in spam and some words maybe usually appear in non-spam. So together the spam probability becomes very high, they will classify. So together naive Bayes classifies something by learning by how likely some of the words or some of the features are to be appeared in any of the classes. So then choosing the class with highest probability. So you can see each word we are calculating. So I have done some examples. So anyway, in order to prevent 0 in the probability, I have added a +1. And then since we are adding +1 to each word, the total word will be increasing. So I have added in the denominator the total number of unique words in the vocabulary. So this is to prevent if some of the count of the words in the class will be 0, means since we are multiplying in the Bayes theorem, it is multiplying the probability, it will be 0, means each and every term will be 0. So I'm just adding 1. So it initiate a small value. 1 by something is something smaller. Since I'm adding here 1, we have to add the number of unique words. So for count of words in each class is +1. I'm adding the unique number of words. So it will be something like total. So because we add +1 fake counts to every unique word. So we are adding that one. So this is how we calculate each word's likelihood calculations. So I'll show you how we have done for the email. So yeah, so you can see here making prediction. Now we can predict the class of new emails. So this is how we classify the spam and non-spam emails. So you can calculate it by the probability given. Okay, sorry. So how to separate the spam and non-spam emails? So that's what we are discussing. So you can see the email text buy tickets now. So after tokenization means you are splitting up each word and checking how much times it is repeated. So now you can see, I think if you have any confusion, you can ask me. Okay, so I'll be repeat. So from our previous calculation, we know for spam, So probability in the word by belongs to spam is 0.01, 0.115. How we got it? So the total number of repetition of by in spam is 2. So you can see here the total number of repetition of the count. So from where did we get this one? So we got it from here. So in spam email 1, then I think it's repeated. Yeah, 2 times it is repeated. So we added here 2. So out of spam email, we have 10 emails. So we add if 10 words as spam. So you can check here. So by came 2 times, then total 10 words we have. So 2 plus 1 plus 1 plus 1 and 1 plus 1 plus 1 plus 1. So that is 10. So total number of words in spam is 10. In that, how much times by repeated? Okay, so this is happening. So we are calculating the probability for each and every words by tickets now. Similarly, we'll calculate the same thing for non-spam also. So the probability means if something is coming as 80%, if it is not means it will come as 20%. So we are calculating, you can see we have calculated that also. So, so how the probability is occurring? So 2 by 10, we are calculating. So in order to prevent the 0, we are calculating it as plus 1. And we are adding the number of unique words. So number of unique words is 16. So this is to ensure the, I said right, why we are adding, we means we are adding the vocabulary signs because we have added a plus 1 here, fake count to every unique word. So the total should reflect in the denominator also. So that's why we are adding the fake ones. So similarly, we'll count like probability of by given spam, probability by is not spam. Similarly, each and every word we are calculating. So together, so the test word was buy tickets now. Similarly, we will calculate for each and every sentence. Buy. So I'm calculating for a normal word like buy tickets now. So you're calculating the word buy. You're calculating for the word ticket. We are calculating for the word now. Then you're multiplying it together. So actually, what is this? So this is something important in probability. So this is the basic theory of the probability. So you need to, so I hope you know the Bayes theorem. So what we used to do in the Bayes theorem. So let me show you what is Bayes theorem. So Bayes theorem is what? Let's consider how Bayes theorem is applied to some of the examples. So Bayes theorem means you have some independent assumptions using different features. So that independent assumptions you are multiplying. So that is my Bayes theorem formula. So there is a conditional probability of an event occurring given that another event by assumption. So if you want to predict something is raining today, you need to see whether you have a cloud, whether you have something like, so for, what are the features for the rainy day? So there won't be sun, the cloud will be very like something like black color, and maybe from the news itself, maybe it will rain today. So there are different features. There can be x1, x2, x3, x4. So this is how you do the Bayes theorem. Similarly, in naive Bayes algorithm, there will be different probability to happen something. Similarly, to classify some email is spam or not, you need to multiply each and every probability of the words. So this is how you classify whether your whether your given email is spam or not. So let's do some practicals. Let me open my Colab. So you can open your Colab, so that you can understand some of the basics. So I hope you are all ready with the Colab. If you have any doubt, you can ask me. Okay. So I hope every one of you are ready with the naive Bayes algorithm. So we'll do a small example in naive Bayes. So you can understand this with a small data set, or we'll just do with small basics. I think it will be clear for those who don't know. So you can open the Gemini, or Google Colab. So if you can't see me, I'll just increase the zoomings. So we'll start. I hope you're ready with the Pythons. You can, I'm giving, if you're possible, you can do along with me. Okay. So let's start with some examples. So I'm waiting, so you can make it ready. And in your syllabus, I can see some of the small data set also. We can go through that also. So let me take the example. Okay. So you can import from sklearn. So that is, I hope you know what is sklearn. It's a library for importing the AI machine learning algorithms. So we are importing naive Bayes algorithm. So I'll explain each by word. So we have a form of Bernoulli naive Bayes. So it's something like Bernoulli is related to Bernoulli principle, Bernoulli NP. So I'm explaining each and word by word. Okay. So that you can understand. So I'm running that one. It will take some time. Now you can import some NumPy. So I hope you know what is NumPy. Yesterday I have given, and maybe if you have any doubt, you can type it in the chat box so that I can know. Okay. So it may take time to run the code. So let's type some words. So it may take some time to run. So I'm waiting for that one. You can do along with me. So it's just running. So I think we have an error. Little bit check what is the error. Okay, I think some spelling mistake. So this is how you import. Okay, now it's imported. Now let me import NumPy also. Okay, that is ready. So that's it. Anyway, I have given the code here in the last of the chat so that you can practice, have a practice. I'll give you later on so that you can have a practice. Okay, don't worry for that one. So this is how you import the naive Bayes. So I'm not going it in a heavy way. So just for your sake. So you can just type some emails. So let me type some emails in a list. So you can just type the same email. So like some data sets like. So I'm going in a slow way to understand the in a limited edition. So like something you can just type some words, limited offers. So you can type with me. Okay. Then you can just type something meeting tomorrow. So let me copy paste some emails so that you can understand. So like this, you're typing some list. So I have typed some list. So this you can type some, any free assumptions as per your requirement. Then you can you can think of it's a small data set. Now you can label which emails are. So let me label those emails as spam, not spam. So you can label it. So let me label. So you can think the first email is a spam, second email is a spam, third email it's a meeting, it's not a spam. Fourth email is a buy tickets. You can think it's a spam. You can just convey your regards to the labels. So now actually you need to extract the text. So I said for each word we need extraction. So in Python itself we have a function same in the sklearn library. So we have a function like feature extraction. So that is in order to extract the features of the text. So I'm doing it. You can do it. Yeah, it's here itself. So it's for counting the words. So it counts the words. Okay. So I'm doing it very slowly so that you can understand. Then actually you need to vectorize. So each words you need to form it as convert the words into numbers. So you have a function. We have actually count vectorizer. So you can see here. So this is, I'm doing it line by line so that you can understand it. Okay. So it's for your sake. So if you want to make fast means you can tell me. So I think there are some beginners. So now you need to transform these emails. So the vectorizer actually transforms these emails into X vector or something like, yeah, so I'm vectorizing it. So you can take this variable vectorizer dot fit transform. So you can actually transform it, this email. So I'm transforming these emails into some numbers. Okay. So now what is happening is, so this is the naive Bayes algorithm. This I'm taking the NumPy for mathematical calculations. And you can think this is my data set. So here it's very small data set. Usually we have some big data set. So now you have some, you want to vectorize each. That means you want to calculate every words as numbers. So that is what is happening here. So it's for the sake of the conversion of emails. Now you are actually putting a model. So you can put, yesterday we have done for the linear regression. Today it's multinomial. I mean multinomial. So we have taken, or you can import some other things also from here. You can import multinomial naive Bayes. So I'm doing that one. So it's for me. So you can take this one. Yeah. So now you have imported the model into a variable. Now actually what doing, you need to fit the curve. You need to fit. So yesterday what we have done in the linear regression, same thing. We are fitting the curve, or you can say you are fitting the naive Bayes algorithm. So now the training is done. So those calculations which I showed you, so it's calculating each word by word. So now you can give a email, test email, that is a prediction. So you can just type something like exclusive. So I'm doing it very, very slowly so that you can understand. So I think there are some beginners also. So exclusive offers now, so that you can see. So to take it into the list. So this is a test email. So what we are doing, so as per the naive Bayes algorithm I have shown you, here we have a data set. We should have a data set to train any algorithm. So that is what is known as AI or data science. So we need data set. And we have to give labels. Since this is supervised learning, I hope you know what do you mean by supervised learning. Yesterday I taught you that is you need proper labels for teaching. So now we are doing each word we need to vectorize. So we have different big emails. You can assume that we have big different emails. Then we are vectorizing it. Then we are calculating the probabilities. This is what is known as training. So this is what is happening in this code actually. Yeah, this you are importing the multinomial from the scalar naive Bayes. Then you are importing it into a variable. Those variable you are fitting the X labels. So you have X, that is the vectorized words, and for each word you are predicting the probability. Now you have tested for, you have a test email. You can predict. So you can predict whether the email is a spam or not. You can predict it using the vector dot. So we need to vectorize the, I mean, vectorize the test email also. So you can vectorize it, vectorizer dot transform. Then you can predict transform emails. So don't worry, I'll give you the codes. So no issues in those kind of confusion. If you have any confusion, you can ask me. Okay. So then I'm giving the test email. Okay. So this is the test email. I have vectorized it. So now you can see the prediction, whether it is 1 or 0. 1 means it will be spam, or if it is 0 means, so you can do the prediction. So prediction is equal to model dot predict. So this is the same code yesterday we used for prediction. So you can give the prediction. Yeah, test vector, prediction. So what is the answer? You can just print and check. So there is some, spelling mistake. That's why the error came. So it's 1. So actually it's a spam email. Okay. So similarly, you can give with different different text, like you can check like meeting, like what you have for non-spam emails, important meeting. So you can just type here and check important meeting. Then you can run the word. So it will give as per your data set. Okay, what data set you have, it will give as per that. So you can see it is not a spam. You got a 0. So this is how you train a data set. Then what is the peculiarity of vectorizer? That is very important. Why we are using this the function vectorizer? So that you need to understand. So as all we know, the scalar feature extraction, that is, this one. So this one we are using it. Machine learning models cannot understand the text directly. Model understand only numbers, so we must convert words into numbers. So every like buy now, limited offers, meeting, tomorrow, buy tickets, everything is needs something like some 1010 binary. So it converts words into numerical vectors. So original email will be in a text format, but you are finding all unique words. So each word will be having its own vector format. So then only it's actually learning the words like buy, now, limited, offers, meeting, tomorrow. So this it converts the sentence into numbers. That is what is happening in the transform. So then while you convert, it's basically making a table, and it's like the algorithms like naive Bayes cannot process raw text, so they need numbers and that. So this is how it works. So you can just check with this. So I'll forward you the codes. So you can just check the training sets again. So you can, okay, then it's a test email. I'm vectorizing it. Now I want predicting it. So what is the prediction? So you can see it's a non-spam. So you can like you can check with other words like buy, buy offer. So I'm doing a new email, something. So you can check whether it is a spam or not spam. You can see, yeah, it's predicted as a spam. That is one. So together, what is happening? So that's what it's happening inside the training set. So the naive Bayes actually converts the text into numerical vector. So that is happening here. So now I think let's go to the previous slide. So actually what is happening? So naive Bayes is a classification algorithm based on probability. So it predicts a class using previous data. Okay, so even you can see the spam email usually contains buy, offers, free, discounts. Normal emails usually contains meeting, projects, schedule. So if a new email contains free offer today, so they may just look similar to the spam email, so it predicts spam. So because it assumes features are independent, it assumes buy, offer are unrelated, even though in real time they may occur together. So the probability of each class per data is used in the form of naive Bayes. So this is what is happening. So I'll forward you the notes. If you have any doubt, you can ask me or you can email me. So actually, for each and every data set, if you want to predict cancer, so you can see here, I have shown you the cancer data set at first. Same, how you can think how the naive Bayes is working here. So you can see each feature X1, X2, X3, X4, it's having its own weights. That is the W. So similarly, you need to know this, the age risk, smoking factors, then family history. So even these are also converted as vectors. So each probability is first the probability of cancer and probability of non-cancer is predicted. Then it calculates the feature probability, each feature, age, then smoking probability, given that it is cancer, family history, given that it is not a cancer or cancer, then X4 weight loss, whether the given thing is cancer or not cancer. Then together it is predicting whether a patient is having cancer or not cancer. So this is what is not a naive Bayes. It is assuming something. So in probability, the two events are considered independent. So even the age is age, smoking, every features, the main thing in the naive Bayes is everything is considered as independent. Why means if it is dependent means there is no relating to take the probability, because it will be dependent means something. If the smoking and family history is independent means no need to consider that one, right? We can consider only smoking. So each and everything is assumed as independent. So that is what this means, that even if we know even B has occurred, it provides no new information that change about our belief. So that's what happening. So I hope, let me introduce you what do you mean by a dependent or independent. So I don't know whether some of you might be unclear with what you mean by the dependent or independent. So you can think of two events, like event A, the first coin lands on the head. Event B, the second coin lands on the head. So similarly, since the outcome of one flip does not influence the outcome of other, so you're flipping the coins twice. So the first flip does not depend on second flip, right? So that is something like dependent or independent. So while if you are considering the probability of both A and B happening, for the independent, you can multiply. That is the main specialty. Okay. So for dependent means you can multiply. For independent happenings, you can multiply. So that basic consideration only we are giving in the spam. So if an email is spam or not spam, you need to check each word, so that each word is not dependent on each other. So probability of buy given spam into probability of ticket given spam. So you have an email, buy tickets now. So whether you're checking it is a spam or not. So like this only Google is working. Spam, you might be seeing like spam, non-spam things. So this is how it's working. So you might need to put more attention towards the probability. I think if you understand probability more, you can understand these things basics. So it's learning the common spam words and its probability. So this is how it works. So which type of email usually contains these words? It's the Google is checking if those words most appear in spam emails, then the new email is predicted as spam. Even real Gmail spam filters are much advanced. Not only naive Bayes they are using deep learning, then the transformer architecture, then the URL analysis they are doing, then the sender's reputation they are using, then the user's behavior they are checking. So everything is done, but the basic probability idea is similar. So this is how they are doing with the, classification, whether you are doing something. So the basics is Bayes theorem. I think I have told something regarding Bayes theorem. So actually, what is Bayes theorem? So I'll introduce you. I think I'm assuming that some of you don't know what is a Bayes theorem. So maybe you'll be learning. You might learn before what is a Bayes theorem. So if something needed to happen, we are trying to find out every features. So if you people need to go outside today, what are the features that you might check? So today should be holiday, then today should not be raining, today should not be very hot, and last but not the least, your pocket should have money. So every features you need to check, right? So that's what actually, and these features are independent. So whether it is raining, whether it is hot, whether your money is your pocket is having money, so these things are independent. Similarly, in a cancer data set, also you are considering everything are independent. So like that, you are actually uh, giving important neighbors assumption. So you can see here, like to predict some email as spam or not spam, you need to check each and every features, that is x1, x2, etc. up to xn. So this assumption actually simplifies. So from each feature, what is the probability that the word given is a feature? So once you people know, right, the probability will be between 0 and 1. If you multiply these things, you will get a probability on dependencies of other features. So I hope you studied the Bayes theorem once before. So you can think of these are different features considering as vectors. P of some email given the class is something like uh, spam or not spam. You need to check with entire features. features means entire words in each class. So you can check, I'll give you the notes, you can read it. So I think I don't have more time to stick on to this, but I'll give you the notes and you can read it and you can check how the Bayes theorem is performing the algorithm of Bayes. So mainly it's taking the posterior probability and each feature they are multiplying. So this, I hope, I don't know whether you are familiar with these terms, but the probability of a given email or the given words are spam or not, it's checking the individual probability. So that's what the basics of. So I'm not diving more deeper into the class. So whether what you're doing, even if you're predicting some models are a cat or a dog or a rabbit, so these types of predictions are done for the sake of machine learning or the Bayes algorithm. So now let's go back to the code. We'll do some more examples. So let me go back to the code. So you can have a look on this. I'll share you this code since we are running out of the time. So next. So let's have a prediction on the cancer Viscon data set. So let me introduce you the data set. So we have a very famous data set called cancer Wisconsin data set. So that is a breast cancer prediction. So you can do a basics of naive Bayes as a beginner. You can do with me or you can try with, I'll give you the basics of the codings so that you can try. So let me open a new code. So you can try here. So let me import it. So from this sklearn. So sklearn is the library function to import this data sets. So yesterday, I think we have done these things. Same thing. So I'm doing it line by line so that you can understand. You can import the load base. So since this we need more time to do, so I'm running out of my time. I'll do something more faster. So we'll import the Gaussian NB or some sort of naive Bayes. So I'm not discussing different types of naive Bayes. I have just explained the normal naive Bayes. And something let me import for the training, testing, and splitting so that you can display the data sets. So let me load the cancer data set. So this is how you load the data set. Yesterday, I think we have done. So it's a breast cancer data set. So it contains actually the details of mainly the cancer patients. So what is it? What does it contain? So it's a foundational multivariate data set used to classify the tumors, whether it is cancerous or non-cancerous, or you can say it's malignant or benign. So based on cell characteristics, so you can extract from the digitized biopsy image. So it's actually extracted from the biopsy images. It's widely used in medical research and machine learning. So you have a total number of 569 instances and a target class of malignant and benign. You have two classes here. One is cancer and non-cancer. You have 30 features here actually. So I'll display the data set so that you can see it very well. So let me load it. So, okay. So this is how you load the breast cancer data set. I think there are some of the beginners, so you can see. So now let me load the features as X. Okay. So before that, you can load the features as X and the target output variable as Y. Okay. Before that, let me display the data set so that you can see how we. So this is how you load a data set and then display data set. So let me show you. For that, we are using pandas. I hope you know the basics of pandas. PD dot. So let me import the pandas first. So import pandas as PD. So I'm doing it very slowly so that you can understand. If you have any doubt, you can ask me, or you can, even if you can note it down and you can ask me through the email also. So data frame. So I'm just importing it. Cancer dot data columns equal to cancer dot feature. Yeah, it's already there. dot feature names. Okay, so now I have imported the data and I want to display it in a form of data sets. What is the error? I think some. Okay, the columns name is something. So now I have done it. So now you can see, let me add the target also, df of target. Yes. Now let me display. So you can, yeah, you can see the data set. This is a very big data set. You have the cancer radius, cancer texture, cancer perimeter in centimeters, and those kind of stuffs. And you have target variables. So these types of things are cancer, and these types of things are non-cancer. So you can see. Let me display the head of. So this is a 5 rows into 31 columns. Just to see the head of the data set, you can display it while you get it. So this is how the data set occurs, what each column means. So this is, I think it's there in your syllabus. So mean radius means the tumor radius. And mean texture means the surface texture. And mean perimeter means the tumor perimeter. And you have mean area, that is tumor area, something else. Then the target means whether you have cancer. So you have those who don't have cancer, it is measured as 0, and those who have cancer, it is measured as 1. Okay, so then you can just type what are the target also. You can just print whatever. So those who have cancer, it is known as malignant. Those who don't have cancer, it is known as malignant. Okay, so those who don't have cancer, it is malignant, and those who have cancer, it's benign. So it's actually, you can print the shape of the data set. So you can print the shape. So whatever, when you get a data set, you have to be familiarized with the data set. So you can print shape. It's, you have 569 patients data into 31 columns. That 31 features are there. If you want to print the features names, what are the features? You can check. Yeah, mean radius, mean texture. So with this, you are trying to check whether your patient is having cancer or not. So like we have said, so this is based on image data set. Okay, so now we're splitting the data. I think yesterday someone asked me how to split the data. So in the text, so let me tell you, we have X train, we are splitting the data. So we are training with 80% of data and testing with 80% of data. This we can do if you have some sort of bigger data. So if you have small data, no need to go for training test split, because you need more number of data, right? So then Y test. So now I'm splitting the data set as 2. So that's it. I have split it. So now the data set is split as per training and testing. And now let me load the model. So before I have loaded, let me load this model 2. And you can see I'm loading as a Gaussian naive Bayes. So it's a type of naive Bayes. I think that is not there in the syllabus to explain. You can explain if you want. Now let me fit the model. So whenever you load the model, you need to fit it. So you can check with X train and Y train. So for training, we are using the training set, that is X train and Y train. Now the training is done. Since the data set is very little, like 569 instances, you can. Now let me add the samples. Check a sample for the prediction. So you can take from the X text. So what are the X texts? You can see that one. X text. This is for testing. So it's having vectors, right? So you added some values. So it's now in the vector format. So with this array, you want to predict whether it is having cancer or not. So you can predict result equal to. So before that, you need to predict the sample as X text of 0. So sample, you're taking the first vector, X text of 0, you're predicting it. So to make it in a 2-dimension. So this is how, so I think, okay, spelling mistake is there. I'm sorry for that one. Okay. So now you have predicted the sample. No, I mean, you have given the sample, now you want to predict. So the result should be what? Whether you have a cancer or not. So model dot predict. So you can give, depend on your cancer size or something, you can predict. Now you can print the result whether you have a cancer or not. So you can see, yeah, you have a cancer with this thing. So you have just checked, you can check what is the dimension of data what you have given. Yeah, you have 31 features here. You can see 1, 2, 3, 4, like the 31 features. So this thing consists of, if you have an unseen data, if a new data is coming, you want to check whether the data is having cancer or not. So the answer says that it is 1, you have a cancer. So this is how you check whether you have a cancer data or not. So this is something bigger, and whatever, when you get a data, you have to familiarize with it. Okay, you can plot some graphs. So here you can see, we have loaded the breast cancer data set. So each patient have different features: radius, textures, area, smoothness. Then you split the data set. Why you are splitting? You can see you have displayed the data set, and then you are splitting the data set. Why you are splitting? So for training data is for learning the patterns, like it is calculating the probabilities and those things. And testing data, you want to check the accuracy or precision or whatever it is. And the model means we use Gaussian naive Bayes. It's a type of naive Bayes because medical features are continuous numbers. So continuous is a continuous data set, like radius, textures, those things, not like just 0 or 1. And what is this code doing? Same like yesterday we have taken, the model learns the patterns of the cancer, and the model learns the patterns of the non-cancer also, using the probabilities. So then how you predict a new data? So you can see here we have predicted something, right? So how the prediction is happening? So naive Bayes calculates the probability of cancer given the features. Each feature it will check. So I hope you understood how it is happening. If you have any doubt, you can ask me. Okay, I have got a question in the chat box. Okay, I'm so sorry for that, I didn't see. Okay, how do we choose different? It's a good question. Different naive Bayes. So it depends on the data set. So you have different models. Like, is there any preference? Means it depends on the application. So like, what can I say? Like, if you have something continuous numbers or decimal float values, you can go for Gaussian naive Bayes. So it's something like text classification. You can see I have used multinomial. If it's like something like binary features, you can, I hope you will be familiar with Bernoulli's theorem. So you can go for Bernoulli naive Bayes. So Gaussian naive Bayes means it's used when the features are continuous. So here you can see the features are continuous, right? Like 7.99, 10.38, 1001. So like medical data, height, weight, temperature, those things. So why Gaussian means? Gaussian means actually it assumes the data follows as a normal distribution. So if I'm explaining this, I need like 2-3 days to explain the basics of probability, like normal distribution, and why the probability shape looks like a bell curve. Okay, it's model P2, right? I'm sorry for that. So thank you, Madam Dilia, Madam. So actually it's model 2. So maybe it learned from the previous data. So yeah, you can check that one. Yeah, it's actually correct. It's model 2 only. Maybe it took the previous model from here. So because we have trained a model with this data set also, right? Actually, it should have error. Since it is a number, it did not throw an error. So it may be like that. So coming to, so thank you, Dilia madam. So coming to the Gaussian. So I was explaining mainly by multinomial naive Bayes will be used for best for classification techniques. So if you are researching or if you're doing any experiments in classification like 1, 0 or binary classification, you can use it when the data represent the counts or frequencies. Like this means that word by appears 2 times, word offer appears 1 time. So you can use for spam detection, sentimental analysis, documented classifications. You can use this. And Bernoulli naive Bayes means when your features are binary, like smoking means 1, 0. You're smoking or not smoking. You have weight loss or not weight loss. So you can use Bernoulli naive Bayes. So this actually we need one day actually, especially to explain the neighbors. So it's a very big topic, especially used in uh, new algorithms. So in the breast cancer example, we have used Gaussian neighbors. So these are continuous decimal numbers, right? You can see here the data set. So after counting the vectorizer, it vectorizes. And for the word counts, we used multinomial. So it's something like the word counts. So all neighbors models use basic principle, that is Bayesian theorem, that is P of A given B is equal to P of B given A into P of Y, P of P divided by P of A. So how the difference is only how probabilities are calculated from the data types. So okay, so I think I'm going more depth wise. So here also we have many things to calculate, like accuracy I did not calculate. So that you can try, okay, you can try from the lab. So if you want any extra session, you can ask me, or you can do an email to me. So this is how you classify something. Okay. So let me go to the next topic. Today I'm having two topics. That's why I was running like something. So it is very tough for me to take, like usually I take even naibias. We need at least 3-4 hours to convey the basics of probability. Then jump into something like algorithm technique. Then we need to jump, at least for programming, we need to load a big data set and do. So anyway, I'm not just going specific way. I'm not going in a broader way. So now let's come into logistic regression. So I hope yesterday you understood the linear regression. So within the time, I know I'm very late because this time is not sufficient to teach a bigger topic like logistic regression, naive bias, and those things. So let me explain logistic regression. So in one word, linear regression, we were predicting some values from minus infinity to plus infinity. In like how we predicted, like we had we used to draw a line from y equal to mx plus c. Then the output can be from minus infinity to any plus infinity. Similarly, logistic regression, you can think we are using it for the classification. So you can see for linear regression, so every data set you cannot use a line, right? What if some is something like classification technique, we need to use some other curves. So if the values were from minus infinity to plus infinity, we can use a line, straight line, so that it can predict any forms of data. What about if the if it is in a classification manner, or if the data the target output is something like 0 or 1 or binary? So for that, you can, for such characteristics data, you can use logistic regression. So let me explain. So like even you can use for binary classification. So naive bias and logistic regression is very similar actually. So and I hope that's why in your syllabus it's just said as together maybe. So these are the things which you need to take time and learn. Okay. So you need to understand the basics of probability. You need to understand the basics of the data. So based on probability, only naive bias is working. But logistic regression is working on this graph. This graph is known as sigmoid graph. So especially naive bias uses which class usually contains these much features. So you saw how it is. Logistic regression learns from weights, then it converts to probability. Naive bias means it's a probability based counting approach. Like how common are these features in each class? But logistic regression is weighted decision boundary approach. Like how strongly does each feature affect the prediction? So like you have an example of cancer data set. So naive bias actually calculates the probability of smoking given cancer, probability of age given cancer, then probability of genetics, family genetics given cancer. Then they're multiplying together and they're calculating the total probability. I mean the product of the probabilities. In case of logistic regression, same way they're doing, like something like you can say into y equal to mx plus c. Then they are converting into probability. So I'm skipping the theoretical parts. I think I can share you the slide and you can read it and you can go through these things. So you can think this is the linear combination features of a regression. So yesterday I said y equal to mx plus c. So same thing in different dimension. So you can think that if it is a two-dimensional data, you can say it is y equal to mx plus c. It's a line. If it is a three-dimensional data, you need to say like y equal to m1 x1 plus m2 x2 plus c. If it is a three-dimensional data, you need to separate by something like y equal to m1 x1 plus m2 x2 plus m3 x3 plus c. So for a two-dimensional data, you need a line. For a three-dimensional data, you need a plane. For a four-dimensional data to separate, you need a hyperplane. So unfortunately, we are human beings. We can only think up to three-dimensional. But the thing is, AI is taking a projection of some of the data into higher dimension. So that is why the linear equation is something like this, y equal to mx plus c. But if you have multiple features, y equal to, you can think this z as y equal to m1 x1 plus m2 x2 plus etc. n xn plus c. You can relate it like that. Just I am skipping some of the in-depth features in the AI. So then you're converting. So you have a small data set here. So yesterday I told if you're predicting some price of a house, you will check the size of the house. You will check the number of BHK of the house. You will check the how old is the house. If you are taking new house, the price will be more, right? So similarly, within each feature you are calculating. So unlike neighbors, it is not calculating each and every feature, but it's taking like a regression, then it is converting into probability. So just instead of predicting different prices, you will predict only whether it is higher or lower price. Okay, you can, I'll give you a basic example. So in regression, in data set, you just checked. So if your student is studying more hours, he'll get marks more, right? 35, 45, 55, 65, 75. But if it is a logistic regression data set, you can think it is of a binary concept, whether he'll pass or fail. So this is something like, what you can say, different, totally different. So mainly linear regression and logistic regression, what is the difference? For linear regression, the predicting value, the target output will be from mainly from minus infinity to plus infinity. And for the logistic regression, it will be binary, something like 0 or 1, something like -1 or 1. So you can think of like that. So the graph for a linear regression is a straight line. Straight line means if it is in a two-dimensional means it will be straight line. That is y equal to mx plus c. If it is in three-dimensional means you need a plane. That is y equal to m1 x1 plus m2 x2 plus c. If it is a four-dimensional means you need a three-dimensional hyperplane to separate. That is m1 plus m1 x1 plus m2 x2 plus m3 x3 plus c. So that for n dimension of data you need to separate, you need n minus 1 dimensional hyperplane to separate. That is two-dimensional, you need one-dimensional line. For a three-dimensional data, you need a two-dimensional plane. You can think, I hope you can think it in different way. But logistic regression, it is actually converting these type of data into probability. So how you can convert, that is something using the sigmoid function. So I don't have more time or much time to explain the sigmoid function. So I'll just give the equation and you can see the graph of the sigmoid function here. So each and every minus infinity to plus infinity value you get from the regression, you are converting into 0 and 1. So this type of data, you are converting into this type of data. I hope you can see. So why you are doing that? If you want some binary outputs, so like you're just checking whether your student is passed or not. In your examination, you are not displaying the entire exact marks. You want to display whether you have passed or not, or qualified or disqualified. So no need to display the marks. So you can perform the sigmoid function so that the linear regression value will be converted to the probability into 0 and 1. And how it is converting to 0 and so I'll give you the equation. So actually P equal to 1 by 1 plus e raised to minus z is the equation. So z means the value which you got after regression, linear regression, you are converting into this format means as z tends to minus infinity. So when the z is very large negative, e of minus z becomes very large because the exponent becomes very large. So exponent graph is like this, something like this, right? So making the denominator very less, so it becomes 0. So if you have any straight line like this, the minus infinity value will be tends to 0 value. So I'm just making it very simple. And the z value will be plus infinity. So I said you, the linear regression value is minus infinity to plus infinity. So minus infinity, you need to convert to 0, and plus infinity, you need to convert to 1. So that is, you are converting this type of graph into this type of graph. So that you have an equation here. I'll give you the notes. You can read it or you can write it and check whether you are getting like that or not. So it's not the time. So we are running out of the time. Okay. So actually, what is happening is I have written the notes and the derivation very clearly. So you have something like probabilities of something, right? You're checking the probability. If a even A is happened with P probability, if even A is not happen, means it is 1 minus P. So P means the probability happened, 1 minus P means the probability is not happened, since the probability sums to 1. So those things you are summing as a linear regression equation. Okay, so I'll have given the derivation. If you want to give notes to students, you can take this from this slide also. So I have given it very, just first you took the linear regression equation y equal to mx plus c. Then you are converting into sigmoid function. Then you get a probabilistic view data. So converting a linear regression data, if you want some binary classification, then you are doing this one. So these things in Python, it's very easy, very simple to do. I don't know how to express it, but you can try the various data set. So that is the main peculiarity of a sigmoid curve. So sigmoid curve means it's very important curve in the mathematics. So to understand the logistic regression, so you need to understand the basics of sigmoid curve. So I have explained it very clearly in the notes. You can follow, because y means so I shown you here, right? So you can see here. So you have some values minus infinity to plus infinity with a straight line. Then you are converting into the probability. So minus infinity will be 0 and plus infinity will be 1. And the middle values, it will have like 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0.5. So that is what is the peculiarity of the. So linear regression cannot limit the output between 0 and 1. But sigmoid fix this problem. So that is the main peculiarity of a sigmoid graph. So I have given the derivation. You can check it. I'll share you the slide. So I'm skipping some of the parts. So mainly, then we are coming to the basics of naive Bayes. So that's why I took naive Bayes first, and secondly, we are taking the formation of what you say, the maximum likelihood expectation. So what is the maximum likelihood expectation? So I think from the word itself, it's very clear what do you mean by the maximum likelihood expectation, if you know the basics. So it is one of the most important ideas in statistics and machine learning and logistic regression, even in naive Bayes deep learning. So a maximum likelihood expectation asks which parameter value makes the observed data more likely. So suppose you have a coin, you do not know whether it is fair or not. So you're checking it by tossing it 10 times, right? So if you get 8 heads and 2 tails, so what is the probability of heads here? So it's not like 1 by 2. It's something like 8 by 10, right? So it's something like 0 0.8, 0.9. So the value that most likely produces the observed data. So so those basics are played in the form of maximum likelihood expectation. So I have given those equations and notes also. You can go for it. Similarly, you can predict the spam emails using the logistic regression. I have given the data. You can check because I'm running out of the time. So let's try to do some basics example in the logistic regression. So you can take the codings. Okay. So let me take the codes since we are running out of the time. Okay. So let's first export, or I mean import the function of logistic regression from the data. So suppose you have a data set. Let me import. So same code sklearn dot linear model. So it's a linear sklearn dot linear model. Sorry. So you're importing the logistic regression. So you can import logistic regression. You can import in that one. So I think it's a spelling mistake. So logistic regression. Okay, now you have imported the logistic. So this is the way how you import it. Something you can import it like that. So let me type some formal data. So you can just type in a two-dimensional data, like something like okay, 1, then comma 2, then comma 3. Some small data set I'm just trying to show you. Then 4, then 5. I'm taking the two-dimensional list. So if you have any doubt, you can ask me. Okay. So actually I have imported. I have inputted the data. Then you can label something. I'm labeling something like first 3 are 1 1 1. So just a sample data. Then others of 0 0. So you can think like person 1 is having cancer, person 2 is having cancer, person 3 is having cancer, person 4 and 5 does not have cancer. So just you can assume, or something else you can assume. Similarly, we can model the logistic regression. So it's model 3 logistics. So let me take from here. So it's the way how you import the model to a variable. Then you can fit the data. Okay. X comma, you're training the X comma Y. So since the data set is very small, I'm not splitting the data set. So, okay. Now the training is over. So now we can predict. So let's assume that like those who okay, we can assume the same data set, like those who study for 3 hours, they are failing the exam. Those who study for 1 hour, they are more than 3 hours, they are passing the exam. And now let me train it. Model.fit. Now the training is over. So you want to predict whether a student passes or fails the exam. So same model you can use. So now what is you have fitted the data. Now you can predict. So predictions is equal to model.predict. So you want to predict some whether if a student is studying for 4.5 hours, he'll pass the exam or not. So I think model, okay, model 2, it's model 3. I'm sorry again. Since the model we have used it again. I think we have some, okay, we have an error here. Should be in a bracket since the predict is a function. I hope you know the basics of the function and those things. So if you have any doubt, you can ask me or you can mail me so that I can give you more examples. So actually here we need to procure the probabilities. So you can check the predictions now. What is the prediction? So it will be, yeah. So if a student studies for 4.5 hours, he will pass. So as per this data set, those who study more than 3 hours, they are passing. So you can check with something like 1.5. If the data set is trained well, you will get a correct answer. So, yeah, see, if a student studies 1 hour, he is failing. So this is how you use it. Okay. For a logistic regression. So actually how it is calculating is actually taking in the form of a linear regression. Yesterday you studied. Then it is performing the sigmoid function. Actually, it's converting the regression value to 0 into probability. How it is converting that I have shown you using the sigmoid function. Okay. So this is how, so let us try with some small data set so that you can study how to import a data set as well as you can do the logistic regression. So I'll share you the codes. The same, I think we can perform the data set. Let me try to import it. Just wait. Okay. From so yesterday I have shown you iris data set. Let us import the iris data set. So there are n number of data set which we get from the, from the SQL metric function. So let me load the iris data set so that no need to describe it for you. So you know these things. Now from the SQL model, we have already imported the logistic regression. So now let's load the iris data set. So this is how you load a data set, which is already present in the SQL matrix. So within the time, I'm just trying to make use of, then you can just display df2 or 3. Yeah. To a variable, you can pass the data set into a data frame. So you can see it in a tabular column. Data frame, F is capital, don't forget it. So iris dot data, you're fetching the data. Then you can, the columns, okay. So now you can see the iris data set yesterday you saw. So the sepal length, petal width, sepal width, you're classifying whether it is a flower or not. Okay. So if you, if you click here, you can see the entire data set. Yeah. You can see the data set. Okay. So this is how you perform the, now you can see the target column also. Let me show you the target. I'm sorry. So this is how you do the coding while you load the data set. So this in the labs and all, you can perform the same operation, but you need to calculate the accuracy, precision, and those things. So let me, I think I am having some errors. Iris dot target. I think the length of values is mismatching. Let me check for it. Okay, what is the error actually? Okay, it's DF3 only. So it was DF3 that was throwing an error. Now you can. So now actually you can use any classes. So you can just train and test the data set here. So you can split the data set. Before that, you need to take the data set into X and Y format. So let me take the petal length of first 100 just for your sake, and target is Y. That is the name of the flowers. So X is the petal length. So I think we have some error. So let me sort out this thing. So, okay, we'll load the model anyway. We have loaded the model. Let it be model 4, model 4 equal to logistic regression. It will load the model. It's already loaded before we have imported it for the last logistic regression. It's logistic regression. So this is how you load the model. Okay, we have an error. So we have a spelling mistake. Logis. Typing mistake. Logistic regression. Yeah, now it will be correct. Okay. So this is how you perform the. So what we have done here. So first we loaded the iris data set. I hope you know what is the iris data set. It's a flower data set. Yesterday I have explained. You have petal length, petal, what you say, petal width. So those things you're doing. Then you loaded the data set here. Then you're converting it to the data frame. Okay, so here you took the pandas data frame to display the data set you can display. So this is how you do the data set display performance, and you can visualize this. So it may take more time. So that's why I'm not visualizing it. And then you can display the target actually here. So now we had an error actually. Sorry. Yeah. So we have, you can print and check the head of the data set. You can check the data head of the data. So it is sepal length, sepal width, petal length, petal width, and the target value is also displayed. for the head, just 5 rows. So this is how you do the training part. Now let's do the training part. So just I'm showing how to display these things. Now you can just perform tests. So I think we have an error for this. Let me check what is the error. Just wait. I couldn't find what is the error. So it's a problem of I think the error happened because our data frame was DF, I think, right? It's actually DF. Yeah, now it will be okay. So next is you need to load the same thing for the target variables. So let me load it. So this might be boring, but you need to perform it each steps. You have to understand these things and do the things. So here also it's 3. So now I have loaded petal length to X and target, that is output to Y. Now let's train it. Yeah, I mean split it for the test train data. Now after it, you can load the model. So we have actually loaded the model. Yeah, here you have loaded the model. And then you can put fit. So model dot fit for X and Y. Okay. So this is how you perform the training. So now it's already trained. Now you can just predict. So what are the predictions for some of the petal length? You can let me add a prediction. So for 3.5 petal length, what is the flower? We can see. So you can see the predictions from here. It will be something like 0 or 1 or 2. Okay, it is in class 0. Okay, so what about petal length with higher dimension, like 26? Let it be. So you can see still it is in 0th flower. So for different values, you'll get. So the main thing is of logistic regression is you can the equation that I have given here, you can go through it, but it is converting a linear regression form into a binary form. Okay, linear regression means you have value from minus infinity to infinity, and it is converting into probabilities. So suppose you have a data set. I have shown you the data set, right? If you have a data set with marks of the number of hours studied, but you don't want to display in marks, you want to just display whether the student is passing or failing with the data. So at that time, you will convert these data into a sigmoid value. So this is the sigmoid equation in order to convert the linear regression equation into sigmoid. So this is used. So I think within the time I have given a small explanation, I'll share you the what you say. Actually, today's syllabus was very lengthy. Yesterday I had got only linear regression. Today it's logistic regression plus naive Bayes. So since you people are running out of the time, and me too, I'm running out of the time. So I have conveyed most of things, but I'll share the notes and I'll share the course what we have done today. So if you have any doubts, you can contact me through the email, or you can contact me tomorrow so that I can give you this explanation. So it's the time for today to say bye to you. So this is Yaser signing off. Thank you, organizers, coordinators, and thank you who heard me from the starting of this session. Thank you and have a nice day. Yeah.
Thank you, sir. Thank you for the wonderful session.
Yes, madam. Thank you.